inside the larynx, you have another cartilaginous structure that is called the epiglottis, that I told you it's like a cap to cover the laryngeal inlet. Now, one thing, remember, this is important. All these cartilages are highly type cartilage, highly, except which one? The epiglottis. Epiglottis is an elastic cartilage. EE, remember, epiglottis is elastic. You have learned this in ANP1, skeletal tissue structures. Epiglottis, E, ear, and elastic, ear and epiglottis. You learned it in ANP1. Okay, so larynx is also called what? Voice box, right? And what kind of structure is it? Cartilaginous structure. What type of cartilages it has? Two types, right? Some are what? Paired. And some are unpaired. I'm teaching you like grade 1 students. Okay. Paired and unpaired. Unpaired largest cartilage is what? Thyroid, which is also called Adam's apple, right? Sensitive to testosterone. Second largest is the cricoid. Make sense? And others are paired, right? Arachnoid, cuneiform, corniculate. You have to remember all these. You won't be able to say no if I just ask you, right? So you have to practice. And inside the larynx, you have the one that moves. That is what? Epiglottis. Formed by what? Elastic type cartilage. All other are what type of cartilage? Hyaline cartilage. Is it clear? Okay. So this is a picture, front picture of a larynx. So you see thyroid cartilage, cricoid, and the small ones in the back. Here you can see these are the small paired ones: corniculate, arytenoid, and cuneiform. Should be somewhere here. Okay. Vocal cords are located inside the larynx, I have mentioned before, and help you to produce sound. Trachea. Next to the larynx is the trachea, which is also called windpipe. Now, if you see the wall of the trachea, it has 3 layers in it. If you make a cross section of trachea, it has 3 layers. Now, anybody remember I said trachea is formed by what? Cartilage, muscle, or both? Both. Very good. So, in the front, you have C-shaped cartilage. That is called tracheal cartilage. Very easy. Tracheal cartilage. And in the back of the trachea, you have a smooth muscle called trachealis muscle. Which is smooth muscle. Okay? So, cartilage and C-shaped cartilage and smooth muscle in the back. That is how the trachea is. Now, if you see how many layers you have here, you have 3 layers. Innermost thin epithelial lining is definitely pseudostratified ciliated columnar, have many cilia, because only air passes through trachea. These are cilia. So innermost layer is pseudostratified ciliated columnar epithelial lining. Then you have another layer, that is the second layer, submucosa. Submucosa is a connective tissue layer. That's the middle layer. Okay. So under this, you have another layer, that is submucosa, like this, and then outermost layer is called adventitia. So 3 layers. Pseudostratified ciliated columnar layer, that is called mucosa. Then under that submucosa, and outermost is adventitia. So see here those 3 layers. And these cartilages are in the adventitia, the outermost layer. See here. This is a cross section including the esophagus. Okay. So this is pseudostratified ciliated mucosa. See the cilia, submucosa, and adventitia. And this is the cartilage. And that's the smooth muscle, trachealis muscle. Okay. This is the real picture, histology under the microscope. So you see those 3 layers, mucosa, submucosa, and adventitia. Okay, so that is the trachea. Now you must remember, I mentioned that 3 structures, last 3 parts of your respiratory system are for what? Gas exchange. Remember that? Respiratory bronchial, alveolar ducts, and alveoli, right? Where gas exchange occurs. So that's the respiratory zone. Here you see those 3 parts. Respiratory bronchioles, alveolar ducts, and alveoli. Alveoli form cluster, like when you buy grapes, you've seen the grapes are together, right? So alveoli are like this, attached to the ducts, like grapes. And so these 3 parts. This is terminal bronchial conductive zone before that. Okay. Now, I also mentioned each alveolus is covered by what? Capillary plexus. Remember that? So capillary is on each alveolus. So you see here, this is beautiful, capillary plexus on each alveolus, which helps efficient gas exchange. So blood, deoxygenated blood comes here, you see, deoxygenated blood gets oxygen from the alveoli, becomes oxygenated, and go back to the heart. Okay. Now, if you see the wall of an alveolus, if I just see one alveolus, the wall is very thin. Wall is very thin because gas exchange can easily occur through the thin wall. What kind of cells are these? What do you think? So this is one alveolus. How many of you remember flat cells? Flat epithelial cells are called what? Squamous, right? Flat. And single layer is simple. So this is simple squamous. Make sense? The wall of the alveolus, simple squamous. Very good. So most of the cells are squamous cells. In between, you have other cells. Like you have 2 other types of cells. These are macrophages Macrophages do what? Anybody? Phagocytosis. Should know by now. Macrophages do what? Phagocytosis. Engulf. So you have macrophages in the wall too, as well as another very important cells. These cells are called type 2 cells, or another name is surfactant secreting cells, or type 2 cells. So in the wall of an alveolus, you have simply squamous that forms the wall, thin wall, right? That helps in gas exchange. But you have other two types of cells. One is what? Macrophages. They do what? Engulf phagocytosis. And another type of cells, those are very important, called what? Surfactant secreting cells. So these cells do what? Secrete what? Surfactant. That's why they are called surfactant secreting cells. Now what is surfactant? I mentioned at the very beginning, a very important fluid must be present in the lung. That is called surfactant. What that surfactant do? The surfactant molecules get attached to the wall. The molecules get attached to the wall, and the surfactant, these molecules, keep the alveoli open, creates a surface tension. That keeps the surface tension, keeps the alveoli what? Open. Is it clear? So, now, you tell me, if surfactant secreting cells are lacking, not here, then surfactant will not be secreted, right? So, that layer of surfactant will not be here. So the alveoli will do what? Collapse. Make sense? Will collapse. And that happens sometimes in infants, premature birth, or if the infant doesn't have surfactant secreting cells due to genetic disorder. Is it clear? It could be due to early birth, premature birth, right? Surfactant secreting cells are there growing, but not yet, functional. That is one thing. So they will grow eventually, right? But if due to genetic disorder they are absent, they will not grow. They will not be there. Okay. Anyway, so that is a clinical condition where the surfactant is not secreted in infants. That is called infant respiratory distress syndrome, IRDS. Infant respiratory distress syndrome, due to lack of or absence of what? Surfactant. Due to lack of surfactant secreting cells. Now if it is due to premature birth, those cells will eventually, if you take care of that infant, right, they will grow and start to secrete surfactant. Make sense? But if it is absent and not going to be, formed due to genetic disorder, it's totally absent. In that case, definitely no surfactant will be secreted there, right? So the chance of death is very high. Okay, so now you know what is surfactant, comes from where, and what is the function of surfactant. Keeps the alveoli open. Without that, the alveoli will collapse, no gas will be able to enter, and that is a problem. Lungs. How many lungs you have? Okay, this is not difficult, right? Are you drawing lungs? Are you drawing your friend's face? Okay. How many lungs? 2. Okay. How many heart? 5 hearts. Okay. So you have right and left lungs, right? They are different. Structurally, they are not, exactly same. What are the differences between right and left lungs? If you see the right lungs is short and broad. So this is right lung. Left lung is long and narrow, like this. So this is left lung. The upper end of the lung is pointed, cone-shaped. That is called what? Apex. Okay? And the bottom is like flat. This is called the base. Makes sense, right? Okay. And the base of the lung rests on a muscle. What is that? Diaphragm. Very good. Okay, so this is diaphragm. What's the main function of diaphragm? Breathing, respiration, right? So the bottom of the lung, that means the base of the lung, is strongly attached to the diaphragm. Strongly attached to what? The diaphragm, like this. Okay. Now, right lung is broad and slightly shorter. Left lung is long and narrow. Is it clear? Right lung has 2 fissures. If you see, fissures means deep cut. Here, you see this is the right lung. One fissure, another. So like 2 deep grooves. This one is called transverse or horizontal fissure because going like this. And this one is called oblique fissure. So you have transverse or horizontal and oblique fissure. So how many cut? 2. Make sense? So 2 fissures separate the right lung into how many lobes? 3. Makes sense, right? If I make 2 cuts, how many pieces will get? 3, right? So this is called superior lobe, middle lobe, and inferior lobe. Make sense? 2 fissures, 3 lobes. Left lung has only 1 oblique fissure. Only 1 oblique fissure. So how many lobes? 2. Superior lobe, inferior lobe. Okay. Now, having the lobes has a clinical significance. Okay. If if you get infection here, okay, it will stay within that lobe. Make sense? It will not easily get into another lobe. If any cancer or tumor occurs here, right, the chance of getting to other lobe is less, unless it is highly metastatic, right? So it will stay confined within that region because they are separated. Make sense? So that is a good thing of having the lobes. Now, in left lung, you have a notch. You know notch, you have seen many notches in the bones. U-shaped area is called notch. So you have a notch here. For the heart, because you know that your heart is sitting here, right? The heart is located here. So this notch is for the heart. That's why it is called cardiac notch. Only in the left lung. Cardiac notch. For the heart in the left lung. Right lung doesn't have cardiac notch. Is it clear? Okay. So if I ask you, write down 4 important differences between right lung and left lung. First thing, the shape. The right lung is what? Short and broad. Left lung is long and narrow. Make sense? Number 2, right lung has how many fissures? 2. Horizontal and oblique. So how many lobes? 3 lobes. Left lung has only oblique fissure, 2 lobes. Is it clear? Right lung doesn't have cardiac notch. Left lung has cardiac notch. Make sense? So just write down those, few physical differences between right and left lungs. And lung has an apex and a base. Now also, you know that trachea comes like this, and 2 bronchi, you already know, principal or primary bronchi, enter into the lung. And this area where they enter into the lung, the right and left bronchus, this area in the lung is called hilum. Okay, hilum. The area where the bronchus, primary bronchus, enters into the lung. Blood supply to the lung. How many types of circulation you have? 2 main types, right? Systemic and pulmonary. So, pulmonary circulation is between heart and what? Lungs, right? Remember that? So, pulmonary circulation is the circulation between the heart and the lungs, and heart sends what kind of blood to the lung? Deoxygenated blood, right? Because blood goes there to get oxygen. So, deoxygenated blood through the pulmonary circulation goes to the lungs. That is pulmonary circulation, one type of circulation in the lung. Another is lung tissue is like other tissues of your body. Lung tissue needs what? Oxygen, nutrition, right? To stay alive. So that is another circulation which is part of systemic circulation. Goes everywhere, including the lung. Make sense? To give oxygen and nutrition. So in your lung, you have both types of circulation, right? Pulmonary, deoxygenated is going to the lung to get oxygen, and systemic, blood is going, oxygenated blood is going to give oxygen to the tissue, right? So pulmonary circulation, pulmonary arteries and veins. Pulmonary arteries take deoxygenated blood to the lung. Veins bring oxygenated blood back to the heart. Systemic circulation, the blood vessels going to the lung are called bronchial arteries. Bronchial arteries and bronchial veins. So bronchial arteries carry oxygen-rich blood because it is systemic circulation to give supply oxygen to the tissue of the lung to keep it alive and functional. Okay. Pleura, the last thing today. Pleura is the connective tissue covering serous membrane. It is very similar to pericardium. Now you tell me, pericardium that covers the heart has how many layers? Anybody? Outer, parietal, inner, visceral. Remember that? Okay. Similarly, pleura has 2 layers. Outer parietal, inner visceral. So let's see. The one attached to the surface of the lung, that is the visceral one, the inner one, and then the outer one. So this is the outer one, called what? Parietal, and inner one is attached to the lung, that is called what? Visceral. Layer. And in between, you have a cavity that is called pleural cavity. The space, okay? Pleural cavity. It's like pericardial cavity. And it has a fluid. What kind of fluid should be there? What do you think? Lubricating, right? Slippery. So when the lung, it's like heart, expands and contracts, friction will be prevented by that fluid. Make sense? Reduces the friction. In pleuritis, have you heard that? Pleuritis or pleurisy is the inflammation occurs and friction occurs. So that causes pain. Itis is inflammation, right? Of pleura, pleuritis. Let's stop here. We'll talk about last few slides in next class. Then we go to respiratory 2.